Shaky on factoring? Watch this video. We've learned 3 methods of factoring, and I'm going to go through them here. The first is the greatest common factor. The second is when the polynomial you're factoring is a trinomial. That means it has 3 terms. And we've learned a few different ways to deal with the trinomial. The first way is called the quick method. There's also a variation on what a trinomial looks like when we use the quick method. And then there's the AC method. And the third type of factoring is difference of perfect squares. Let's get rolling. For any polynomial expression we get, the first question we have to ask is, do the terms have anything in common? And if so, we factor out the greatest common factor. So we're going to take each piece of this one piece at a time. I'm first going to look at the coefficients, 10, -15, and 20. And ask myself, do they have any factors in common? And they have a 5 in common, and so I am going to divide out a 5 as part of my monomial factor. Now, what a lot of students do is they think that we're just dividing out a 5 and it goes away. However, whatever we're dividing out has to be written on the left as part of one of the factors. Now I'm going to look at the next part, which is the x's. This has 7 x's. This has 5 x's, and this has 3 x's. So I want to say, what's the very most number of x's that they all have in common? And they all have at least 3 x's. So I'm going to factor out an x to the third on each of them. So I'm going to show that I'm dividing that out as well. And then when I write it over here, it's going to be part of that factor that is being factored out. It's not being taken away. It's just being written as one of the factors. Then I'm going to look at the last piece of it, which is the y's. And I'm going to say, do those have anything in common? Those two have 2 y's, and this one just has 1. So at most, they each have 1 y. So I'm going to write 1 y for each of these. And I have to put 1 right here. So you'll see that whatever we're dividing out is going to go on the left of our parentheses. So I'm going to put a parenthesis. So this right here is one of our factors. It doesn't just disappear. So then when I look, I'm going to deal with the numerical parts, and I'm going to say 10 divided by 5 is 2. And if we want, we can skip over to the middle. -15 divided by 5 is -3. And 20 divided by 5 is 4. So I just did the numerical part. Now I'm going to move on to the x's. This has 7 x's in the numerator, and we're dividing out 3 of them. That leaves us 4 left over, so we write x to the 4th. In the next term, we had 5 in the numerator and 3 in the denominator, so that leaves us 2 in the numerator, and so we write x squared. And in the last one, you can see that x to the 3rd over x to the 3rd is the same number of x's, and so we can consider that as canceling as an equivalent of 1, so we don't need to write that there are any x's left over, because that's the equivalent of the number 1. Then I'm going to look at the y's, and we can see y squared over y. There's 2 y's and 1 in the denominator, and so we're going to have 1 y left over. Y squared over y is another y. I forgot to put the plus with my 4. And then we can see that the y over y, again, is an equivalent of 1, and so this will cancel out to be the number 1. So here's what's left over. Now, my last step is to always look at each of my factors. This is a factor that's just a single monomial. So nothing's going to happen with that, but I want to look at what's inside and say, do they have anything else in common? I just want to double check, and they don't, so I'm done with factoring. That is called factoring the greatest common factor. That's going to be the very first step you take with every single problem. You have to ask yourself, is there a greatest common factor? All right, now we've got a polynomial, has nothing in common, but I notice that it has 3 terms. Terms are separated by pluses and minuses, so this has 3 terms. If that's the case, I want to see if it's set up to be in our trinomial structure. Our trinomial structure is that the first term has an x squared in it, the second one has an x, and the third one is a constant. X squared, x constant. If that's the case, that means we can factor it. And what it will end up looking like is a set of binomials that are multiplied by one another. Notice there's no operator in between because we're showing multiplication. So we have to ask ourselves, okay, how do we factor this? And the first question we need to ask is, what is the coefficient of the x squared? And you can see that there's nothing right here, which means it is a coefficient of 1. If it's a coefficient of 1, that's great news, because that means we can do the quick method. A lot of students, when they learn the AC method, do that every single time, and they waste a huge amount of time because the quick method is so much quicker. So if that coefficient is 1, then we use the quick method, which means we can go straight to the answer. No steps in between. To do the quick method, you're going to ask yourself, what multiplies to the C value and adds up to the B value? So I think to myself, okay, I've got negative 18. I want to come up with numbers that multiply to negative 18. So I'm thinking of, what multiplies to negative 18? 3 times 6, 2 times 9, 1 times 18, except it's negative 18. So that means one of these has to be negative. So maybe negative 3 and 6, but it could also be 3 and negative 6. Either one of those could multiply to negative 18. Before I get too much farther, I want to stop and think to myself, okay, what are we going for? We're going for what adds up to negative 7. So I look at all of these and I think, well, those aren't going to add up to negative 7. And I think about 2 and 9. 2 and 9 don't add up to 7, but I know one of them needs to be negative. So if I made the 9 a negative, 2 times negative 9 multiplies to negative 18, and 2 plus negative 9 adds to negative 7. So those are my numbers. Those are the numbers I'm going to use in my answer. So I first say to myself, I need to put an x and an x at the beginning of my two binomials, because I know x times x makes x squared. And then I am going to use these two numbers that I just figured out over here, 2 and negative 9, as my constants in the binomial. Plus 2 minus 9. There's my answer. It is factored. That's the quick method, because all you do is say what multiplies to C and adds to B, and then put the numbers right in the binomials. That is called trinomial quick method.
So this one looks similar to our trinomial, but it's a variation on it. You can see it's not quite x squared, x constant, but it's close to that. So you can see we've got the x squared and the x, and then here's a term with a number but no x, which is what x squared x constant is. But then you can see that it's got kind of the same thing but backwards. It's got a y squared in this term, and the middle term has a y, and the first term has no y. So this is called the trinomial variation, and we're still going to use the quick method because we notice that the leading coefficient here is 1. So when we see that, we know it's going to be the quick method. So we know our answer is going to be a set of binomials being multiplied. We're going to look and say, okay, what makes x squared? We know that it's x times x. And then we've got a similar situation here at the end. We've got a y squared. What makes y squared? Well, y times y. So I'm going to put those at the end of each binomial. And then we're going to treat the numerical part just the same as we would. We're going to say what multiplies to 12 and adds up to 8. What multiplies to 12 and adds up to 8? Well, I know that 6 and 2 multiply to 12 and they add to 8. So that's going to be the number part that is the coefficient of the y. So we've got a 2 and a 6. They're both positive, so we're going to have x plus 2y, x plus 6y. And we're done. That's called the trinomial variation quick method.
All right, let's take a look at this one. 3 terms, trinomial, x squared, x constant, nothing in common. So this is a little bit more complex, and this is where we need to use the AC method. So instead of saying what multiplies to negative 10, we're going to understand we're talking about A, B, and C as our 3 values associated with this equation. And we're going to take the A value and the C value and multiply them together. So 4 times negative 10. That would give me negative 40. So I'm going to ask myself, what multiplies to negative 40 and adds up to 3? I know. Negative 5 times 8. Negative 5 times 8 adds up to positive 3, but it multiplies to negative 40. So I'm not going to just plug them into binomials because this is a more complex situation. What I'm going to do is this AC method. I'm going to do it very quickly here. If you want to go back and watch that particular video lesson, you can watch it more slowly and in more detail. But what I'm going to do is rewrite the first term and rewrite the last term, minus 10. And then I'm going to take this middle term, 3x, and split it up into a negative 5x and an 8x. That's what these two numbers are for. So I'm going to rewrite that as minus 5x plus 8x. Now, at this point, I know I need to really focus on the two halves of this. And this middle operator, whether it's a plus or a minus, I'm going to write it nice and big, and I'm going to write it nice and big below. Now I'm going to focus on the left half and say, all right, I'm going to factor the greatest common factor out of these two, and then I'm going to factor the greatest common factor out of these two. So 4x squared minus 5x, all they have in common is an x. So I'm going to factor that out and put that on the left of the parentheses, and what's left over is 4x minus 5. And then I look at the other two, 8x minus 10, and they have a 2 in common. And when I factor that out, I'm left with 4x minus 5. So now I need to look at these two big halves. I've got this half right here and this half right here. And I say, what do they have in common? And I can see that they each have a 4x minus 5 in common in parentheses. So I'm going to take that 4x minus 5 in parentheses and put it on the outside of my parentheses. And then I'm going to say when I factor that out, when I factor this out, what's left over? What's left over is an x. And when I factor that out of here, what's left over is a plus 2. All right, we have just factored it using the trinomial AC method. Again, if you're still shaky on that, go back and watch that particular lesson video. All right, one more type of factoring. You can notice that this has two terms, and the first term is a perfect square, and the last term is a perfect square, and the middle is subtraction. If that's the case, then it fits the structure of difference of perfect squares. And we are going to, again, have two binomials multiplied. Notice there's no operator in between because it's multiplication. So I can say, what times what makes x squared? Well, x times x makes x squared. And what times what makes 100? 10 times 10. Now we know with difference of perfect squares, what happens in our binomials is a plus and a minus. If you're unsure about that, go back and watch that lesson video in detail. This is called difference of perfect squares. Note about difference of perfect squares, no matter what the order, just keep things in the order that they come. So this is difference of perfect squares because we've got a perfect square and a perfect square and subtraction. So 144 is made by doing 12 times 12. That comes first in the expression, so it comes first in the binomials. The last term is x squared, and that's made by x times x, so that goes last in the binomials, and then one of them is a plus and one is a minus. And with any multiplied binomials, it doesn't matter what order they come in terms of each individual binomial. Now this next one, we've got a perfect square and a perfect square, but we've got addition. So that is not difference of perfect squares. In this case, since there's no greatest common factor, this is going to be prime. When you're wondering how to factor a certain polynomial, you need to utilize that flowchart that I created for you. The first always, is there a greatest common factor? Always, always, always ask that, and if there is, factor it out. Now, you're going to have a monomial factor and then a polynomial left inside the parentheses. Then you look inside the parentheses and say, hey, how many terms does that have? Could I factor that even more? I might not be done. So depending on how many terms it has, gives us a different direction. It has two terms. You ask yourself, hey, is this difference of perfect squares? And if it is, factor difference of perfect squares. If it's not, you can't factor it that way. The only thing left to do is look at the very end, look at all the factors just to double check that there's nothing else you can do. If that leftover polynomial has 3 terms, you have to ask yourself, oh, is this a trinomial in our structure, x squared x constant? Is it in that form? And if the answer is yes, then you say, oh, this is the crucial. Does the a value of the x squared term, is it equal to 1? Does it have a coefficient of 1, meaning you don't see any coefficient there? If that's the case, you're going to do the quick method. Don't waste your time doing the AC method. If the leading coefficient is more than 1, if it's a number, then you're going to use the AC method. If it's not in the form x squared x constant, then there should be nothing left to do. But always double check. Look at all your factors at the end just to see if there's anything else that could happen. If it has 4 or more factors, the only thing you can do is factoring a greatest common factor. So just double check that there's nothing left in common to make sure you factored out something that's big enough. All right, we're going to try a whole bunch of examples for you to see my thinking process. First question, always, greatest common factor, do they have anything in common? Oh, they do. They each have an x. So I'm going to factor out an x. Now, you can or cannot write the division of the x. I'm not going to write it because I can do that part in my head. So if I factor out an x, I'm left with an x squared minus 8x plus 15. Well, I might not be done. I need to look at the polynomial that's left on the inside and say, could I factor that? So, how many terms does it have? It has 3. Is it in our structure, x squared x constant? Yes. All right. Maybe we can factor it like a trinomial. So then I have to look at the leading coefficient and say, is this coefficient 1? And it is. So I know I can do the quick method. So I know this inside part is going to be some binomials multiplied, x times x, and then I say, okay, what multiplies to 15 and adds up to negative 8? Well, negative 3 times negative 5 multiplies to positive 15, but adds up to negative 8. So I need to know that I need to write negative 3 and negative 5 inside, but then I also had this factor right here of x, and I can't leave that off, otherwise my answer will be incomplete. So I need to include that x as well. Then I look at each individual factor right here, x minus 3, nothing in common, no difference of perfect squares. Same with this one, so I know I'm done. Next one. First question always, anything in common? Oh, they all have a 3 in common, so I'm going to factor out a 3. When I do that, I'm left with x squared minus 10x plus 25. Well, I might not be done, so I need to look at that polynomial inside. And when I look inside, I see there's 3 terms, x squared x constant, so I know that is going to be multiplied binomials. That's going to be a trinomial, and I have to first say, okay, what's the coefficient of the x squared? It's a 1. I know it's going to be the quick method. Was a little early on my parentheses here, but now I know it's a quick method. I know that's going to be there. I know the 3 is going to be out in the front. I'm going to just write that to begin with. Then I ask myself what multiplies to 25 and adds up to negative 10, and I realize it's negative 5 and negative 5. So I'm going to say x and minus 5 and minus 5. Now the only possible variation here is that you could take those binomials that are the same and rewrite them as x minus 5 squared. That is an option, but not mandatory. We've got to have that 3 out in front. Right, we're going to ask that same question again. What do these have in common? I'm going to look at all the coefficients. You can see that they all have a 3 in common, so I'm going to factor out a 3. I'm going to show how we're dividing that out, but it's not going to go away. Whatever I put under there that I'm dividing out is part of my monomial factor that's at the beginning. on the left. Then I look at the x's and I can see that this one has 2 x's, this one has 2 x's, and this one has 3 x's. So the very most that they each have is 2. So I'm going to factor out an x squared. So I'm going to factor out an x squared from each term. So if you can think of the language to yourself, I'm factoring it out, not I'm dividing it out. Then I'm going to look at the y's. This has 1 y, this has 3, and this has 2. So the very most that they all have is 1. So I'm going to factor out 1 y from each. I'm going to put that over here on the left. Then I put my parentheses. Let's see what's left over. 9 divided by 3 is 3. And you can see that I've got x squared over x squared. That cancels to make 1. Y over y cancels to make 1, so all that's left is the 3. In the next term, negative 15 divided by 3 is negative 5. I'm going to look and see x squared over x squared cancels to make 1, but then I've got 3 y's in the numerator and 1 y in the denominator, so that leaves me only 2 y's, so I'm going to have a y squared left. In the next term, plus 6 divided by 3 is plus 2, positive 2. Then I'm going to look at the x's. There's 3 in the numerator and 2 in the denominator, so that leaves me 1x left over. Y squared over y leaves me 1y left over, and there I've factored it. Then I look at what's left inside and I say, can I do anything with that? Well, it's got 3 terms. Could it be a trinomial? I look to see if it's set up in our structure, x squared x constant, or some variable squared, that variable and constant, and it's not. So I know that I am done, and we are factored. Next one, greatest common factor. Do they have anything in common? Nope, the first one has an x, but the second one doesn't have an x. The first one is got a 9 and a 16. Neither of those have any common factors, so there's nothing in common. So now I have to think, okay, well, how many terms does it have? Oh, it has 2 terms. 2 terms means it could be difference of perfect squares. So I asked myself 3 questions. Question 1, is the first term a perfect square? 3 times 3 makes 9. X times x makes x squared. So 3x times 3x makes 9x squared, so the answer is yes. Is the last term a perfect square? Yep, 4 times 4 makes 16. Is the operation subtraction? Yes. If you get yes, 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 then you can do difference of perfect squares. So you're going to write your 2 binomials, and you're going to say 3x times 3x makes 9x squared, and 4 times 4 makes 16. And then you say one of them has to be a plus, and the other has to be a minus. It doesn't matter which is which. And I'm going to look and say, 3x plus 4. Anything we can do there? We cannot. There's nothing in common. That's not difference of perfect squares. I look at this one, 3x minus 4, nothing in common. That's not difference of perfect squares, so we know we're done. Next one. Anything in common? That's the first question we always ask. Nope, nothing in common. How many terms? 3. Oh, is it a trinomial? Well, let's look and see if it's our trinomial structure. X squared, x constant. It is. Fantastic. All right, take a look at the first term at the coefficient. The coefficient is a 6. So that is not the quick method. This means we need to do the AC method. So I'm going to multiply a times c. 6 times negative 5 makes negative 30. So what multiplies to negative 30 and adds up to 7? Negative 10 times positive 3. No, that adds up to negative 7. So I want to do positive 10 times negative 3. Oh, that adds up to positive 7 and multiplies to 30. So I'm going to write my steps. First step, rewrite the first term, 6x squared. Rewrite the last term, minus 5. And then I'm going to take 7x and split it up into these 2 terms, plus 10x minus 3x. We just uncombined like terms. That's what we did there. We took like terms and we split them up. 7 is split up into 10x and negative 3x. So now we want to write this middle operator really big and rewrite it down here. So now what we're going to have is a negative starting out my second half. We'll get to that. So now what we're going to do is look at the first half, oops, all the way over here to the x, and look at the second half. So I'm going to factor the first half. What does 6x squared and 10x have in common? They have 2x in common. When I factor out a 2x, I get 3x plus 5. Then I look at 3x minus 5. Nothing in common. So we have to write something. So we're going to write a 1. So I'm going to factor out a 1. Now what's important to realize is that what we're factoring here is a negative 1 because we've got that minus right here. So when we factor out a negative 1 from negative 3x, we get positive 3x. And we factor out a negative 1 from negative 5, we get positive 5. Now when I do that, I'm going to just double check in my mind. Negative 1 times 3x makes negative 3x, and that's what I have right here. And negative 1 times 5 gives me negative 5, which is what I have right here. So I know that what's in my binomial is correct. So now we're going to look at this, there's my cursor, this big half right here and this half right here and say what do they have in common. And what they each have in common is a 3x plus 5 in parentheses. So I factor that out, put it on the left, put it in front of the parentheses, and then what's left over? When we factor this out, we're left with a 2x. I cannot tell where my cursor is. 2x. When we factor it out over here, we're left with a minus 1. So we write 2x minus 1, and now we have factored it. AC method. Next one. We did this already. Let's move on. All right, take a look at this one. Anything in common? Nope, I don't see anything in common. How many terms? 2 terms. Always have to check for difference of perfect squares. Is this first one a perfect square? Yes. Is the second one a perfect square? Yes. Is it subtraction? Yes. If we get yes, 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 then we know that our answer is going to be difference of perfect squares. So we're going to have 2 binomials multiplied. X times x makes x squared. 5y times 5y makes 25y squared. 1 is a plus, 1 is a minus. I look inside and say, anything I could do here or here? Nope, we're done. Let's take a look at this one. Anything in common? Oh, there is. These have a 5 in common. That's the first thing I need to do. So I'm going to say I'm factoring out a 5. I'm not dividing out a 5. I'm factoring out a 5, which means it still needs to be written in my problem. So I factor out a 5 and I get x squared minus 4. All right. Then I have to stop and look and say, what's going on in here? Could I factor that? How many terms is it? It's 2 terms. Well, if it's 2 terms, it could be difference of perfect squares. Is this difference of perfect squares? Yes. Is this a perfect square? Yes. Is this a perfect square? Yes. Is it subtraction? Yes. So I know that this part is going to be split up into difference of perfect squares. X times x makes x squared. 2 times 2 makes 4. 1's a plus, 1's a minus, but I have to write that additional factor of 5 so that things are complete. I look at my binomials at the end, x plus 2 and x minus 2, and there's nothing more we can do with those, so we're done. All right, how about this one? Same question we ask every time. Anything in common? Oh, they do. They have a 2 in common. So I'm going to factor out a 2. 2. Factor out a 2, I get x squared plus 9y squared. All right, then I have to look inside and say, could I do anything inside? How many terms? 2 terms. Have to think about difference of perfect squares. Is this first term a perfect square? Yup. Is this second term a perfect square? Yup. Is it subtraction? Nope. So that cannot be difference of perfect squares because it is subtraction. So this leftover polynomial in here cannot be factored anymore. Now, some people might be inclined to write prime because it can't be factored. However, we have already factored it into 2 factors. So this original problem was in fact factorable. It had a greatest common factor. We're done. Let's take a look at this one. Some of you might right off the bat think, oh, that looks like AC method, x squared, x constant, and the leading coefficient is 4. You might dive right into AC method. However, don't make more work for yourself, because the first thing you need to ask is there a greatest common factor? And in fact, there is. We can factor out of 4. So when I factor out of 4, I put it on the outside of the parentheses, I'm left with x squared plus 6x plus 9. So in fact, I didn't need AC method, because take a look what we've got left over. We've got a trinomial, x squared, x constant. However, the leading coefficient right here is a 1. So I know it's going to be the quick method. So much faster. X times x makes x squared, and then we have to figure out what's the other part of it. Before I even do that, I'm going to put my little 4 over there, right? We got to make sure that we write down that other factor of 4. So now I'm going to focus and say, okay, what multiplies to make 9 and adds up to 6? Well, 3 and 3 multiply to make 9. 3 plus 3 is 6. So I'm going to do plus 3 plus 3. Again, this is the one where you could write your answer as 4 times x plus 3, that whole quantity squared. Optional, not mandatory. All right, let's take a look at this one. 2 terms. You might think, difference of perfect squares. It doesn't look like that. Before we do a single thing, we need to ask greatest common factor. Do they have anything in common? Oh, look at that. This has 3 x's and this has 1 x. So they have each at least 1 x in common, and this one has a y and this one has a y. So they each have an x and a y in common. Again, if it helps you to write what you're factoring out underneath, you can do that. So let's see what's left over. 3 x's over 1 x leaves me 2 x's, so I have an x squared. Y over y cancels and equal to 1, so we're not going to write that. You can see in the next term, the x's and the y's each cancel because they're over themselves, but then we still have a 4, so we're going to have x squared minus 4 left over. All right, that's a nice greatest common factor. But we got to look at what's left over inside and think to ourselves, could we do anything else? 2 terms, difference of perfect squares. Is it difference of perfect squares? Is x squared, where's my cursor? People, where's my cursor? That's a perfect square, 4 is a perfect square, and it's subtraction. So in fact, that can be factored into difference of perfect squares. We say what times what makes x squared? X times x makes x squared. What times what makes 4? 2 times 2 makes 4. We know that 1 is a plus and 1 is a minus. Doesn't matter if you put the plus first or the minus first, but then we cannot forget that xy. That is also one of our factors. All right, let's take a look at this one. First, I think anything in common, and they do. They all have a 3 in common, and they all have an x. Now, whenever the first coefficient in the very front, the very first one is a negative, then when we factor out a number like 3, we're going to factor out the negative of that number. I'm going to write it a little farther down so we have room for our dividing. So I'm going to show a negative 3, right? That's our rule because we want what's left over in the parentheses to start out as a positive. So I'm going to divide out a negative 3. I keep losing my cursor. Where is it? It's over there. I'm going to divide out a negative 3 from each of these terms. I'm not dividing it really, I'm factoring it out because I'm still writing it below in my answer. But then they also all have an x in common. So I'm going to put an x. So I'm factoring out a negative 3x. So what's left over when we factored out a negative 3x? Negative 15 divided by negative 3 is positive 5. X to the third over x is x squared. Negative 3 over negative 3 is equal to 1. So I'm going to put just a plus. And x squared over x is x. And then I'm going to look at this last one. Negative 18 divided by negative 3 is negative 6. and the x over x makes 1, so I've got that. All right, I factored out a negative 3x. Then I say to myself, am I done? I don't know. I got to look at this thing. What do we have? X squared x constant. That looks like our trinomial. So I look at the leading coefficient, the x squared coefficient, and it's a 5. So I know this would require the AC method. Let's think about that. 5 times negative 6 makes negative 30. What multiplies to negative 30 and adds up to 1? Well, 6 and negative 5. 6 and negative 5 multiply to negative 30, and it adds up to positive 1. So this whole inside, I'm going to do the AC method. So I'm going to write 5x squared and minus 6, and then I'm going to split up this plus 1x into minus 5x and plus 6x. I like writing the negative 1 first. It makes life a little easier. So then I'm going to go down here and make my plus nice and big. Make my plus. I'm going to say, what do these first two have in common? They each have a 5x. So I'm going to factor out a 5x. And I'm left with x minus 1. And I look at these two guys over here, and they each have a 6 in common. I'm going to factor that out, x minus 1. I look at my two big terms, and I say, what do they have in common? They have an x minus 1. What's left over when I factor that out? 5x plus 6. Now, I'm not done. What did I forget? Can't forget, this negative 3x is a very important piece of the problem. It is one of the terms, so it has to be written down here in our answer. So we include all the terms that have been factored.